Yes, ma'am, you are.
Okay. Okay.
You may proceed to start your presentation. Tell me when you want me to move forward with the slide.
I have already forwarded. Should I present? Yes, this one. Okay. Good evening. Myself Bindu VA, Assistant Professor, Rajagiri School of Engineering and Technology, and I am doing research under the guidance of Dr. Manju Somanath, National College, Trichy. Today I am presenting on the topic elliptical cryptography for Bitcoin security. My presentation contains its abstract and how Bitcoin security can be implemented using elliptical cryptography. Mathematics has addressed many complex problems in the past and is consistently proving avenues for present-day security problems too. This time, we understand the interesting mathematics powering the security structure for Bitcoin. The complex mathematics that goes on provide much more and ensure a critical component in the security apparatus implemented in the Bitcoin protocol. The solution is addressed by elliptical representation and the science of cryptography, forthright by ECC. We attempt to present the elliptical SCCP 256K1 y square equal to of the form y square equal to x cube plus b and its relation to security enforced for the Bitcoin network. Bitcoin is facilitated through the usage of Bitcoin wallet, which will take many forms like online wallet, hardware wallet, or mobile wallet. Once the Bitcoin wallet is installed in our system, we are ready to make transactions through Bitcoin. We can view it like the email address that can be shared with friends and others so that they can pay you and vice versa. When the Bitcoin wallet is installed, it generates a unique address for us. Elliptical cryptography is the use of elliptical to generate public and private key pairs over a finite field. These public and private key provides security to Bitcoin network. Next slide, please. An elliptic curve is shown in the figure. If you draw a line on the elliptic curve, that line will intersect 3 points. And if you add the 2 points, P plus Q, the next point will be on the elliptic curve. Next one. The send or receive Bitcoin using ECC. These are the following procedures. User A wants to send Bitcoin to user Z. User A will share the public key with user Z. User A opens the wallet and indicate to send 1 Bitcoin to user Z. User A's wallet will generate a transaction message with details as text message that contains sender information, receipt information, amount. User A's wallet uses the private key and group the text message to generate a digital signature that is unique to the transaction. It also creates a file called the text file. This text file pushes as a broadcast to the Bitcoin network to various nodes. Each node will broadcast again to the nodes until the recipient, that is user Z, uses the public key and decrypt the file to receive the Bitcoin amount. During this whole time, the file is retained in the memory pool. Next, I will explain about the point addition in elliptic curve. A general elliptic curve is of the form y square equal to x cube plus ax plus b over a prime field p. If the discriminant delta equal to minus 16 into 4aq plus 27b square is not equal to 0, that elliptic curve can be used for cryptography purposes. If P and Q are any 2 points on the elliptic curve, then the point addition can be done as follows. Assume that P plus Q equal to x3 y3. Then x3 equal to lambda square minus x1 minus x2 mod P. Y3 equal to lambda into x1 minus x3 minus y1 mod P. Where lambda is, if P equal to Q, it is the first formula. If P not equal to Q, it will be y2 minus y1 by x2 minus x1 mod P. Next. This is the model of and SCCP 256K1 ECC curve of the form y square equal to x cube plus 7. This elliptic curve was used for Bitcoin security problems. Next slide. And example 4, a prime value 67. This curve was in which a equal to 0, b equal to 7, and the elliptic curve was defined over the prime field 67. We then proceed with solving the elliptic curve. We identify the generator point, then generate a public key, generate the user A's private key, and generate user A digital signature. These are the procedures done using elliptic curve. Next slide. These are the steps in Bitcoin security implementation. The first level component belongs to the owner, that is the user A, and contains the nonce. The second level component are derived from the message M, digital signature RS, and order of G is given as N. The third level component is the encryption process, and the fourth level component resembles the decryption once the recipient, that is user Z, get the message. Next one. And verifying the digital signature with the public key. These are the procedure. The detailed processes in concept is given as follows. Verify the values of R and S, which is between 1 and n minus 1, which is the digital signature value. Then we calculate W equal to S inverse mod n. Then calculate U equal to Z into W mod n. Calculate V equal to R into W mod n. Then we calculate the point xy, that is equal to UG plus VW. Where U and V are obtained from the steps 3 and 4. Then verify the validity of the signature, that is AR is equal to X mod n. From if the calculated value of R does not match with the present value, then the Bitcoin is not transferring. And using an example, by taking 67 over the prime field, the points are explained here. The generator point G is given in red hue, that is 222. Then we calculate VW and UW, that is the component of the digital signature. We have VW and UW. VW is in black hue and UW is in green hue. And the coordinates of the point, the coordinates of the point C is equal to UV plus VW. Sorry, UG plus VW. Then if the digital signature is matched with the value, then the Bitcoin is transferring. Next one. The conclusion, history has time and again proved that various offshoots to mathematics has provided robust solutions to advancements in technology which has stood the test of time. Mathematics will testify to be called as the queen of sciences. Next.
Thank you very much.
These are my references.
Bindu.
Thank you.
Thank you very much, Ms. Bindu.